Back. This is the AWS well-architected stream on Twitch. If this is your first time joining, I'm going to explain a little bit what is that we are doing here, and it won't take long. It's just a sec. If you guys are already familiar with what we are doing, please just hang tight. This would not take more than 5 minutes. So the well-architected framework, if you're not familiar with it, is our description and questions to help architects build good solutions for the cloud. And the idea here is to remove this idea that software architecture is complex, hard, or some kind of black magic that you're only for the third circles and initiated. And this is not true. We can make sure with a little bit of effort and best practices, we can ensure that applications are safe, well-performing, with decent cost structure, and all that the cloud can offer. So this is the whole idea of this show, showing you how to implement this architectures and how it is. And it all starts with this document, the well-architected document. You can see here it's available on PDF and on Kindle. And it is divided into 5 sections. So it is security, reliability, performance efficiency, and cost optimization, and operational excellence. So today we are talking about operational excellence, the ability to run and monitor systems to deliver business value and continually improve supporting process and procedures. So today is going to be a lot of continuous delivery, infrastructure as code, this kind of things. If you're interested in the other topics, I highly recommend you take a look at the previous episodes. We've been going through the questions and design principles and implementation of those things. And the way we are doing this is iterative and incremental. So in the next episodes, we're going to come back to each of those pillars and dive deeper and build more code around these things and automate more and go on and on until we are well architected. So this is what we are doing. Without further ado, let's jump to the operational excellence pillar on page 33 of this document. So let's review the principles for operational excellence and make sure that we understand the main points here. And if you have any questions at any time, feel free to fire on Twitch chat. I'm here listening to you. The whole idea here is to be interactive. This is not me talking at you, it's me talking with you and helping you guys be successful with AWS. So let me know what you would like to build and how you would like this to go, okay? So the idea here, the principles that we're going to keep in mind while implementing this pillar is performing operations with code and try to be as automatic as possible and reduce human labors and the problems that comes with it. We're trying to align operations with business objectives, collecting metrics that make sense. And by the way, if you can't hear me well or if there is any problem with the audio or video, feel free to let me know. And making small incremental changes, we're going to talk a bit about why this is important and not accumulate a lot of work to be done in these automations and how to test for unexpected things. So this is the whole idea. And to guide this, there's a bit more. Learning from operational events and failures. So keep track of the things that happen, and adding this to your knowledge base is quite important, and making sure that those are current. And we're going to be talking more about runbooks and playbooks and how these things should work. Ideally, the most you can take things out of here, out of operations, procedures, and playbooks, and more into operations with code, the better. But sometimes things must be assessed by a human, such as a recovery or something like this. So we're going to talk a little about that as well. So without more, let's jump into the questions. That's the meat of the well-architected program, let's say. What is best practice? What are the things that we are using? So all the well-architected pillars are sets of principles and questions, essentially. And the questions will guide you through thinking about the architecture in one aspect, and you should be able to answer those. So here are those first questions about best practices for the cloud operations. This is a bit too abstract, a lot more than we can cover in this session, but let me give you guys a few pointers and references to get us started. First, I'd like to reference 2 books. So, there is some reverb on the video. Let me hear if, yeah. So I'm adjusting the mic here just a bit. I will talk a bit further from it. And well, I hope this is better now. And the first 2 resources that I'd like to mention are the continuous delivery site and book. This is built by Jess Humble, and he's got a lot of the ideas here and the patterns. For example, BlueGreen deployments are very important. And all of that is on this continuous delivery website. That's weird. Let me try to silence that. And thanks. Let me try to adjust the audio capture a little bit. Let's hope this is better. So let me know if things do not improve. Okay, I can try to make it better. And so continuous delivery, the continuousdelivery.com website. Let me paste this to you guys if you want to follow. This is what I'm talking about here. It provides a lot of those best practices, and there are, especially the first book it's a bit old, it's 7 years ago, but still mostly valid, and you can surely get lots of good ideas from here. And we are going to talk a lot about implementing those today. Another thing that can help you guys is this Release It book from Michael Nygaard. This is a bit more digestible, I guess. Not so. I like the way Michael writes it, and it's surely one of the most important references we have. I hear he's working on the 2nd edition. I highly recommend you check it out. Okay, so let's start with some examples. One that I would like to start, as we talk a lot, is BlueGreen deployments. So BlueGreen is this idea of how do you keep applications up to date with 0 downtime. So the idea here is that instead of updating applications in place, we can just route through and
the environment and switch routing. So instead of making a deployment to the green environment, we can provision a blue environment and just go with a switch routing. And this is great because if you have some kind of a problem, you don't need to undeploy and deploy again. You can just roll back the router and instantly get back to the new environment. So this is a bit of an idea. And before you switch routing, another good idea, and I will be also referencing a lot of Martin Fowler's work here. So he's got another one called Canary Deployments. So before you make a release, a good idea is to make a small deployment and send, for example, 5% of the users and see how it goes, instead of shipping all the traffic at once, because you will see if the new version is stable, if it can receive traffic, if it performs well, and so on and so forth. And by the time you feel safe, you can keep switching traffic until the old version is gone. And of course, this can be automated, like your router component can be a load balancer, can be your DNS name. There's a couple ways to implement this, as we're going to see today. And the many ways to do it, we're going to do a couple examples, but take a look at the full article if you'd like to know more. And as you can see, we are rolling to new environments as an idea, so we don't need to keep the machines alive for very long. We can just spin up an instance or a container and shut it down when it's done working, and all the data and all the things that would live on the server would go with it, so you don't need to keep state in the servers as they come up and down pretty quickly. So another good idea here is immutable deployments. So instead of having a set of changes performed to a server, it's a better idea to have this all in a single step in an immutable server or an immutable image. It can be a container image, it could be a Docker image, but the whole thing is when you have mutable servers, you have three different phases. You have to provision the machine, you have to configure, and you have to deploy. When you use immutable servers, this is all the same thing. When you bring a new machine up, the image can already contain all your code, all your dependencies, and everything baked in, so it boots faster. By being faster, it requires less margin, so it costs less, and it's better to maintain, as you don't even need to maintain it. It's just immutable, and so on and so forth. So, but this leaves thanks for the feedback on the sound. I don't know why there is a bit of an echo. I will try to get it better for the next one. Let me know if it's too bad. I've been trying to adjust this, and I will get to it. But so far, I guess it's better we go with what we have. I hope that's not too bad. I will try to speak a bit lower and not so high and get it a more comfortable volume for everyone, because we are going to be here for a while talking about this, right? So the speakers are muted. I actually have a headphone plugged in, so it's definitely not feedback. It's probably reverb from the room itself, so it's not much we can do here. And the immutable, this whole idea has it's very, very nice, But there is a point where it gets hard, and it is this last tier here, the database. Sometimes you can have separate databases like this, but most of the times you want to share this database, and this is a bit hard to evolve when you have database changes, right? So another idea that helps with this is CQRS. So there's another article from Martin Fowler on this. I will be using his articles for reference. And so this is CQRS, or Command Query Responsibility Segregation. And the idea here is that instead of having a single database for the model and the reads, you can write the commands to one database and update the state in another, and this makes it easier because those things are cached differently, so you can keep sending commands and processing events while applications are updated. So this would help you to implement BlueGreen in a bit more complex scenarios. So yeah, I just turned the mic away from me. I guess it's just reverb from my direct voice. So I will show how to do it with CodeStar services and try to do it a bit differently, because Code Deploy can do it, but it's not out of the box. So it does require some tuning, and we are going to see a couple ways to do it in a bit more easier way than Code Deploy does it. Code Deploy is better when you have mutable servers that you have to change the deployment into the server. If you're going to use immutable deployments, you don't even need Code Deploy at all. You may not need Code Deploy at all. You just need CloudWatch metrics, and we're going to talk a bit more about that. So I just referenced this continuous delivery, BlueGreen, Canary release, immutable servers, CQRS, and because those are the kinds of answer that you would put to this question. So when we talk about what best practices for cloud operations are you using, those are the kinds of things that you want to look into. And we are going to implement a bit of those in the next question. So about configuration management, how are you doing configuration management for your workload? I see people doing basically two ways nowadays. There used to be a lot of discussion on this, and nowadays everybody uses Git anyway. So, and we are going to show some options for Git. But basically, there are two branching models. So there is this article called a successful branching model for Git. This is pretty popular, and it's the first time I saw how to work with branches in Git in a way that you have your master branch, hotfixes, release branches, develop feature branches. And the idea here is that instead of writing to the master, you pull to a separate branch and merge back when things are ready. And the idea is that master is always in a runnable state. Master can always go to production. By the time you merge to master and push, it's live. Or even another branch, you can have master and develop, for example. Develop can go live on push, and master may require manual input. So if you're doing this is one way to do it. But there are some controversies around this. So I guess they call it feature branches, single branch, or something like this. Let me let me see. There is certainly something more specific. The whole idea is user feature flags. So let's see if there is Martin Fowler article on this feature toggles. So this is the idea that instead of using branches, you just use feature toggles. Like it could be any kind of configuration to enable or disable features, so you can develop on a single branch. So everyone can just deploy to master and release it and leave the thing toggled off, and just deploy as many versions as you want with the thing off, and when it's ready to go live, you just toggle the feature on. And the whole idea is that this makes deployment and management of your code base much simpler. If you are using Git branches and things like this, it may be the case that someone creates a branch and leave it open for too long, and when it's time to merge back, it's a huge pain, or you don't merge too often. So there's a lot of people who prefer just committing to the single branch, just go straight to the master, and use feature toggles to hide things that should not be seen by users yet. So those are the two answers I would consider when doing configuration management. It's Git, of course, and how you're using branches, how are you checking in configuration with your code and things like this. So this is the idea here. Let's move on to the following questions. And how are you evolving your workload while minimizing the impact of change? And here the best answer I know is the BlueGreen deployments, or the idea is BlueGreen, but it could be blue, green, red, black, any amount of colors that you want. And the key to this is AWS Route 53. So the way I would implement it is on Route 53. So let's go there and show you how this can be done. Here, when you create a hosted zone, say I have julio.com, for example. This is not mine, but you can create anything you want here. And on routing policy, you see we have 5 different routing policies here. Simple will answer the same query with the same address every time. Weighted will send different proportions of traffic to different locations. Latency will respond with the closest endpoint to the user. Failover will always answer with the primary response unless it fails a health check, and then it falls over to the secondary. Geolocation will respond to the closer answer geographically. And you can combine those in different orders. For example, you can use fail latency and weighted to always return the closest to the user, but even though you can weight traffic and things like this. So to do BlueGreen deployments, we can do on weights. So you can set the weights and say, hey, I'm going to ship some percent of the traffic to my data center and another percentage of the traffic to another place, and go on and on until if you're a Canary deployment, for example, you send 5% of the traffic to A, and as your metrics go live and you see that the environment is healthy, you shift more and more traffic to it. And everything that you can do on AWS. Yeah, so BunnyFX. So the idea here is there are many ways to skin a cat, right? You can
do it on the DNS level with Route 53. You can do it on the distribution level with the CloudFront. You can do it on the load balancer level with ASG swapping. I would not recommend ASG swaps entirely because your app may have a lot of different parts. They're not necessarily servers. If you are using only servers, ASG swapping would work, but consider that your app may have S3 buckets, Lambda functions, and a lot of things that live outside your auto-scaling group. And when you use weighted DNS or CloudFront, you can just route your entire app to a different place. And the problem here, the issue here is with these TTLs. So according to your TTL, this is how long it will take for your deployment changes to be propagated. So if you say, if you set value too high, for example, 1 hour, it may take up to 1 hour for all caches to revalidate and pick up the new addresses. If you set it to 1 minute, it will pick in 1 minute. You can shift traffic, but it will cost more as you will query the DNS much more often. So there is a balance here, but definitely take a look at the routing policies for that, as I think it's a better idea than swapping the ASG, because as I said, there's a lot that can live outside the auto-scaling group. Okay, and you have to keep in mind that everything we do, I'm showing here in the console, but you could do the same thing with the AWS CLI. So if you don't know the command line interface, you can run this on Linux or Windows or anywhere at all. And there is a Route 53 client. So Route 53. So you can just change your record set. And change the things that change your proportion of traffic with the CLI, or even in the SDK. So in AWS, Amazon.com/tools, there is the SDKs. And for example, if you're using JavaScript or Java or Python or PHP or whatever language you're wanting, we support most of modern ones. And here is Route 53. And there is a call with the same name, change resource record sets, for example. So the idea here is that either through the command from the web console or the command line or the client, the SDK clients, this will all reach the same web service behind the scenes and will make the same changes, and you can automate so that, for example, if you're, and this is not by BlueGreen deployments, this is not for new versions only. You can perform all sort of interesting things. For example, if you have an e-commerce website and you can deploy 5 different versions of your landing page and see what has a better conversion and drive more traffic to what converts better and things like this. So you should take care of the thing. So we are in here for 30 minutes now, but if you have any questions, Mother Games TV, please feel free to ask. We are here to talk about anything. If there is anything that doesn't make sense, or if I should repeat, just send. I can recap, and so everybody can pick up from where we are. The whole idea here is to be beginner inclusive. So we are going to dive deep, but I am very happy to bring anyone aboard. If there is anything I say that doesn't make too much sense, I know my accent is a bit weird. I'm Brazilian, by the way. So just ask and I can speak again and go back to any of those topics. Okay. So yeah, just to recap the first questions, we started talking about best practices for operations. There's a couple links in the chat for the practices that I find most important. And we talked a bit about the Git and configuration management styles, about single branch or multi branches and things like this. And now we are talking about how do we evolve while minimizing the impact of change. And the best idea here is immutable deployments with BlueGreen. So immutable is important because if you don't change your servers, and I highly recommend this, in my applications, I don't even have root access. Once a server is up, it's up, and it will do its thing until it's gone, and that's it. So this makes mistakes much less frequent because either you test the image and it's either right or not. So you don't screw up, you don't do anything by accident, it just lives on. And the blue-green thing is what I was talking about with DNS, and there are a couple ways to do it. I highly suggest you do it with DNS. You can swap from the green environment, instead of changing the parts in your environment, because it's so hard to synchronize and make sure that everything happens at the correct time. You can just provision a new environment, a blue environment, and route to that, and route a bit of the traffic to that, and keep routing more and more until you can delete the old environment, and this is this Canary release. So blue-green deployments, Canary releases, and immutable deployments make a perfect match, and this will help you evolve your workload while minimizing the impact of changes. And another key thing here is making those changes small. So there is always that guy in the development team. I was this guy for many, many times. And he just keeps his work in his branch, and it takes weeks until he merges back. And when it's merging back, it's a whole mess, step on everybody's toes and things like this. So for example, let's think of Amazon, the Amazon website, the Amazon.com. I have some example here. This is Amazon.com in 2008. But back then, the watches were not so smart. iPods were filled with MP3 that cost us a cent each, and this kind of very weird things that we all remember, I'm sure. But what I'd like to show you guys is what's behind that. So in 2008, almost 10 years ago, this was the back end of the website. This DevStar diagram, each dot here is a separate service maintained by a separate team with independent deployments. Imagine how does this look now. It's just impossible to manage this by hand with servers that you know the name. So the more immutable and automatic and, well, unmanaged by humans, better. Just so you, this is a number from 2013. We had 50 million deployments. That would be on the main website. This would be one deployment every second and a half. So there's no time to, get into a service, change configurations by hand and things like this. So everything is just deployed and from the code base itself, right? Because we have this whole idea that here at Amazon, if you can't fit a team with 2 pizzas, it's too large. Some pizzas can be really large, but this would be 10 to 15 people. And the key this is why infrastructure as code and automation and those techniques are key, not only to scaling the software, but scaling the organization as well, scaling the company. It's just as much about the business as it is about the software. So how do you monitor workloads to ensure it is operating as expected? And we've been through this in many other episodes. The idea here is mostly CloudWatch. We're going to talk a lot about CloudWatch. So let's take a look at, let's sign into the Coldwater Console. And here you can see everything that your environment is doing. I have a couple alarms. My billing estimates were surpassed. I have some network load balancers under the line, but this is nothing that worries me. The idea here is you can create monitors for everything, right? You can monitor server performance, API gateways, load balancers, elastic cache, and everything can be monitored here. So, for example, on ELBs, you can see the latency of your app. So this guy here is probably not too good. We're going to see a couple ways to make this a bit better instead of creating metric by metric, but the idea is that you should have a monitoring environment, and of course there's lots of partner tools such as New Relic, Datadog, Splunk, and many others that can help you monitor your workload and ensure it's operating as expected. But one thing we don't do is pager escalation. So I highly recommend you guys take a look at PagerDuty. I think it's what everybody's using these days. There are a couple alternatives, but well, something like PagerDuty is very important to make sure that alarms don't go unnoticed. So the thing here is that PagerDuty will page operations and send a message to them, and if things don't work, it will scale to the manager or to the owner or whatever your escalation logic is, and manage events in a bit more intelligently. So this combination is pretty powerful. Take a look at and they are very nicely integrated. We're gonna talk a bit more when we have an environment running. I want to reach to the infrastructure as code part pretty soon. And when we deploy applications, we're going to talk more about monitoring and things like this. So how do you respond to unplanned operational events? Here is where you should take a look at your runbooks and failover logic. If you remember on Route 53, there is the failover mode where you can shift traffic to one location or to another according to environment health. Let me show you guys where it is again. So on the Route 53 console, there is this health checks where you can define your health checks and make DNS failovers when you need them. So this is one thing, using Route 53 to respond to automatically when something bad happens. But the idea, what you have to think is, what's your strategy? We have some strategies for disaster recovery, a disaster being an unplanned operational event. And the thing is, you can have your images and just spin them on when something happens. For example, you migrate to another region and spin the instances back. Or you can have full environments configured on both places and just switch traffic. It's a matter of considering how much liveliness you want, how fast you want this transition to go, and how much it will cost. If you want real no-stop failover, you need to have, for example, the application live in both sides and just shift traffic in DNS as I was talking. But if you don't want to spend too much, you may just take images and backups and make sure everything is safe on S3, for example. And in the case of an event, you script the migration to run it everything else. What you don't want to answer here is anything that happens by hand. Because when an unplanned operational event happens, people will be stressed and make mistakes and make the operational event much worse. So I highly recommend this is completely automatic and tested, right? And I'd like to show an example of this. This is Netflix, by the way they do it. There's a demonstration of Visceral. So Visceral is their visualization tool, and here you see a graphic of traffic going to 3 different regions. So this can be done of course, this can only be done by the DNS or by the global CDN, by the content distribution network, because by the time you have an ASG, it's already on a region. So you can see that when the error rate here increases, it starts shifting traffic to other places. So it's redirecting traffic to the healthy regions. So what someone deployed code with a bug here, something like this, and it will automatically shift traffic. Yeah, sure. I will upload it I will upload the ZAC right after this, no problem. But if you look through Visceral on YouTube, this is just a YouTube video from Visceral, and it will shift back the traffic and run the whole thing automatically. And this is how it's done. And so how is escalation managed when responding to unplanned operations? So this is the pager. Basically, what is your PagerDuty setup? I'll ping the sysadmin first. If he does not respond in 5 minutes, I'll escalate to the manager, to the owner, to whoever can make something, or perhaps notify 2 people at the same time, 2 teams, or whatever is happening. And this may be according to the severity of the operation event. For example, if you have increasing error rates, for example, this can be triggered to someone. If you have an outage that's pretty more significant and someone else may be called. If you have a security issue, well, then this is much bigger of a problem, and you may need to call marketing, press, and prepare for some really big trouble, so you should ping someone else. And the idea here, again, the most important thing is not to do this live, not to try to run this while the things are going on, and just go through the things automatically, because when the event itself is happening, you can't make sure that the things are going to be as planned, because it's already unplanned. So the more automatic this can go, the better. Okay. So this is how to respond to unplanned operation events and take these responses. With this is most the questions. Let me show you guys a bit more of how to implement this. So I would like to start with ColdStar, because this is the whole idea of continuous delivery may be intimidating to some people, and I would like to show it from the start and in a very simple manner how we can do this. So let's create a new project from scratch. So here is we can have CodeStar create many kinds of projects for us, and what it will do is it will create the repo, the pipeline, the build, everything that's required from Git push to production. So Ruby and Node are very cool, but there's no actual build. So let's pick Java that has a build step so you can see how build works. And again, this is not only the technology as a language, but also the runtime. So we could run Java on Beanstalk, on EC2, on Lambda, and things like this. I will show how to do it on Elastic Beanstalk first, because that's quite easier and what I think most people would want, but we're going to show this a couple other ways. So I will call this TW Java Demo 1, for example. And we have two options for Git repos. Code commit is our private Git repo as a service, and GitHub, of course, is public GitHub. And your choice here is basically if this is a private enterprise thing or if this is a Git open source project or something that's outside your control. Because on code commit, you would pay per user, and you can't do this on open source. So if you're doing open source, I highly recommend you use GitHub, of course. So GitHub, you have to connect to GitHub. It will OAuth and back and send the tokens, and you can safely authorize the CodeStar to create repos on your behalf. And here's what it will build. It will take the source on GitHub. When there's a push, it will build automatically using code build, run the tests, and deploy to Beanstalk and monitor with CloudWatch. So this is one way to do it. Right? I will select my key pair. I already have this, and it's just a regular EC2 key pair. And it will take a while to provision this. This is why I have one already pre-baked here. This EB Java is already done. When it's through, you're gonna have an endpoint to your app. Here I have my hello world, right? And here's the source on GitHub. So with this, you can I can just clone this, and here's just a welcome. It's mostly unmodified. I will open this on a text editor so we can play a bit on Atom, and just to show you guys how this works. So here, what we have is this structure. I will on my CS EB Java folder. So this is a Java project, and as usual, it's a Maven project. Here you can see the dependencies, the build, configuration, everything that you have on a typical Java project, right? And with a build spec, this is when you commit, when you do a git push, it will go through those steps, right? We can see here on CodeStar that first it will go to the source, then it will build, and then it will deploy. When you build, it will use this build spec file, and this is the instruction that will be followed by code build, right? So code build will run those phases: install phase, pre-build, build, post-build, and commands, and generate a zip artifact. So this is the recipe for your for your build. So the MVN var exploded, and the copy, this is what will make your Java app, your Java package, right? And this is what's going to be deployed. And in Elastic Beanstalk, you can set up how you want it to go, how you want it to deploy, and how you want your app configured with this .eb extensions. So if you take a look here, there's an sshd.config that updates Python, install Python Devil, install GCC, install Bottletree. So you can this is to tell Beanstalk, hey, when you deploy this app, when you provision the machine, but before you deploy the code, install these packages, create this case file, and run these commands. So this is, you can say how you want your Beanstalk environment to be. So when it spins instances on your behalf and deploy your code, you can have your drivers in place, your dependencies correct, your packages installed, users created, services up, and things like this. Just check this EB extensions configuration. And with this, this is all we need. So let's make a change here just to see how it goes. So I'll go to the Java file. Here is my hello world controller, and I will change this to hello Twitch, and see how it goes. So just push, it's already here. So I will open my GitHub desktop. Here it is. Pick this project. It's this EB Java Demo 1. You can see the change here, and live change. And commit, push. We can see, we'll see it in the repo in just a bit. So here's this repo on GitHub. We can see our changes pushed. And in a while, what we're going to see is see that code build already picked up my progress. It's already going through it and going through my sources and pulling the thing from GitHub. It will start building the thing, running through the commands that are in my build tab, and then deploying to Elastic Beanstalk. So if we go here in Elastic Beanstalk, another important thing that I want to show is the monitoring features. So Beanstalk is baked with lots of excellent monitoring features, and I will show it. And if you're not familiar with Beanstalk, you have apps and environments. I have this apps, the old app, the app name that was created, and this environment running. And you can do all sorts of cool things with environments. For example, if we are doing the BlueGreen deployment, you probably want to clone this environment, so you can just clone environment and say this is environment 2, for example, and make sure it's available and things like this. Generate a unique ID if you need. Of course, all of this can be done on the command line and SDKs as we are talking, and it will soon be up. So here on our app, we have 2 environments. One is already up, one is waiting, and we're going to see what difference this makes in a while. And talking about monitoring, here we have the monitoring dashboard for this app, and the most important CloudWatch metrics, so you don't have to sweat it too much, and take a look at the alarms and the health of your environment. And here's the key part on operations. So this isn't enabled for this environment. I will need to change this config. It would take a bit, but the thing is, take a look at the requests and latency percentiles. So you want your requests to be here in the 200s and the 300s, and not a lot of stuff here in the 400s and 500s. Same idea for latency. If you have a bit more of latency in your 99 percentile, it's okay, probably. It may be a cold start or something like this. But if you start to see high latencies on the lower percentiles, this may be a problem, right? So this is, and you should alert on that, trigger on PagerDuty, and so on and so forth. Let's see how ColdStar is doing with our deployment. So you see that it succeeded, and when we hit the endpoint again, you see the hello Twitch deployed. So this is just what it takes. And here, let's see on code on Beanstalk. We can see here the CS-EB Java Demo 1 app is one environment, and the environment 2 is not yet up, I guess. Let's wait for a bit. So this is a good thing about BlueGreen deployments. I can wait until this deployment takes however long it needs before I shift the traffic and make some permanent changes. So we're going to take a look at more about BlueGreen in a while. Let's just do something else while this environment goes up. And what I want to show you is how to do the same thing, but with Lambda. I know that serverless is a big thing right now, and you can check it out. It's you can do it with Java, with ColdStar, just the same. And just need to pick the AWS Lambda start, or let's pick JavaScript for a change. So Node.js on AWS Lambda, for example. And so Twitch.js demo on GitHub, and connect to your GitHub, same thing, same process. And as JavaScript doesn't have a build step, the AWS code build will do mostly nothing. You may have a build step if you use Babel, test, and things like this. So you may or may not have this build process in the middle, but well, we'll see. And the whole idea is very similar. It will provision everything you want, but instead of using Beanstalk, it will use CloudFormation. So let me pick I have a version of a Lambda project pre-built. Yeah, Go tasks, exactly, this kind of thing. So here is a Lambda project, same idea, but if we check on GitHub, and by the way, this is the blank file new project you can create on your own GitHub or take a look at mine anytime. And you can see that instead of those .eb extensions, and because it's not on Beanstalk, Beanstalk already knows how to deploy software. Beanstalk has its own recipes for making deployments and creating the load balancers and creating the app servers and all the scaling groups and all that. And Lambda and with CloudFormation will have nothing of this. So everything is described in this CloudFormation template. So here is the YAML template, and it specifies two Lambda functions, this get world function, get hello world, that is this endpoint, and this post hello world, that's another endpoint, and you can see the code there. And the idea is pretty similar. The difference is that instead of deploying to Beanstalk with the Beanstalk tools, it will create a stack in CloudFormation using this template. So if you don't know CloudFormation yet, here it is. Let me open a new console for CloudFormation. And here it is. This is our Twitch JavaScript demo. It's probably live already, and you can see that it creates everything that's described on that template. It will create one thing, create other thing, and when it's done creating all the things that it needs, you can see here all the resources that were created. And on the end, on the outputs, you'll be able to see the endpoint and the things that were created there. So let's see here on our DWJS demo. If it's already live, no, it's still building, and it will be live in a second. So the whole idea here is to show you two different ways to do infrastructure as code. If you do on Beanstalk, it's a bit more automatic, as Beanstalk has a lot of that baked in and done. It knows already a lot about the app environment, and you don't need to specify everything by hand. But if you want to use other services such as EC2 directly or Lambda, take a look at the CloudFormation template, and you can use these templates as a start and just keep adding resources to the template. Here it is the YAML. And well, you need more functions, you need a message queue, you need everything. All you need to do is add this. You can see this is serverless function. And it's just one of the element types that CloudFormation can build. So type reference will show you the CloudFormation resources. And here you can see that everything on AWS can be defined by CloudFormation. For example, if you would like an auto-scaling group to be created, this would be the example YAML to do it. So you can create anything, and the whole idea is that you inherit all the good things of software development to infrastructure management. So you don't see that, you don't have that issue of looking to a server and thinking, who put this here? What is it doing? When it was done? You can use the same software configuration management techniques to infrastructure. So if you add it to YAML and commit and push to your Git, you can see when it was done, by whom, attached to each ticket, and completely bound to your software development process, right? Well, if there's always this question about YAML or JSON, and I'm definitely a fan of YAML. So here's the same thing in JSON, and you can see that, well, here is not a dramatic change. Mark, here you can see that it's pretty much the same, but take a look at the functions. So here to get the AZs, you need to invoke the get AZs function. And to make a reference, you have to do this ref launch config thing. And on the YAML template, this is just fn get AZs or ref launch config. So the YAML tends to be a bit more precise, but it's a bit harder to debug. Yeah, much more, but it's a bit harder to debug, right? Debugging, I think that debugging braces is easier than debugging spaces in YAML. So make sure you have YAML linked. You know, I don't know if you there's this tool called YAML linked that I run on every change. And there's a command line version of this just so you can take a YAML file like the one I'm searching in the CloudFormation templates here, for example, and copy, and just make sure that you're not missing a space or anything. Okay? And a very important thing, a very important part of this is, as our infrastructure gets bigger, those templates can get really, really big. So there are two resources for handling that. One is nested stacks. So you can see here that there is an element type called CloudFormation stack. So you can have a CloudFormation stack defined within a CloudFormation stack defined within a CloudFormation stack. For example, if you have data network, database, and application tiers, those can be defined in different stacks, and the whole thing is composed, so it creates all or none atomically, and if you delete the root, it will delete everything else. So the whole thing about nested stacks is that life cycle is bound. When you delete the parent stack or update the parent stack, this change is propagated through the whole tree. Another important resource is called Formation Cross-Stack References. And this is with this import value functions. And the idea here is that you can import a reference from one template into another, but their life cycle is not bound. So if you have a network tier that lots of other people use, and you don't want to bind the life cycle so that when you delete something, you delete the network tier, for example, it would be catastrophic. You can just export the network names to another template and import with import value. So this is how you can compose your CloudFormations to reflect your architecture without being like this huge template that's hard to maintain and things like this. Okay? So, but that's it. 2 ways to automate things with CloudFormation or Beanstalk. But Beanstalk is probably done with our changes, so let's get back to that. Close a few windows. See here on Beanstalk, and let's see what it has done with our environments. We have 1 and 2. 1 is green, and let's see what's hosting it. What is it hosting? It's hosting this Hello Twitch. And on the environment 2, it is hosting the Hello World. It's hosting the old version because this one was cloned and this one was live deployed, so they are hosting a bit of different things. And now here comes magic. Remember the blue-green trick we were talking about? So I would like the new version, the environment 2, to replace environment 1. Well, one thing I could do is add those to Route 53, create a DNS record, and make those wait traffic between those. This is what would happen in prod. But if you're in dev and test and want to do it quickly without changing the DNS and waiting it to propagate and things like waiting prod and things that may have a higher TTL and things like this, you can just come here into Beanstalk and swap environment URLs and say that environment 2 now should point to environment 1, environment 1 now should point to environment 2, and swap. So it may take a few minutes for this to take place, as this is changing the CNAMEs behind the scenes. But after it replicates and invalidates cache, and here you have to always keep in mind that this is a DNS change. So if you have a bad DNS server, some DNS services from internet providers, instead of returning an error, for example, they return an advertisement, and this can really make things difficult if your DNS doesn't work correctly. So check it out, your DNS configuration, and if your DNS servers are doing well. Okay. So here in this Hello World, we should have its Hello World yet. And Hello Twitch is still Hello Twitch. Again, it may take a while. It may need a cache refresh. So let's check, for example, in Opera and a new browser and see if it's still the same thing. Yeah, it's not replicated to my DNS yet, but in a while you will see. You can't believe this works. It's just a matter of waiting for the DNS to replicate and invalidate the cache, and this in my office seems to be higher than the default. It may take a minute, but we will get there. Okay. So the idea here is to show that if you're not familiar with DNS and managing weights in automating this, you can just swap environments URLs on Beanstalk, and it would be the same thing. And again, here you can load and save configs and restart the servers and do a lot of stuff that is very troublesome to do in other environments. You would have to write scripts for each of those operations, and Beanstalk already have this pretty simple. And just to make sure everyone understands, the notion here is that you could just get on upload and deploy and see your versions and say, hey, I don't want this version on this environment. I want to roll back and deploy this one, for example, and hit deploy, select the environment, and go. But this would be not ideal because it would be changing this, and if it is receiving traffic, it would have downtime and errors for the user. So a better idea is to just swap DNS and switch traffic around. But of course, that spinning up a new environment and doing this kind of thing is better for a reliability perspective, but will surely incurring more costs as you need both environments up at least for a while. As EC2 now builds per second, this is not too much, so you only pay for the seconds that you have both environments up. So it would not probably make much of a difference nowadays, but you have to always think about the costs of the solution, right? And here is seen like a pretty good trade-off, right? Let's see if it's already switched. Oh, not yet. Not yet, but I hope so. And well, another good thing is that Beanstalk does not cost anything extra. You only pay for the instances you use, so you can have as many environments as you want, and this is not going to cost anything else. So with this, we've shown how you can easily automate pipelines. And by the way, CodeStar is totally configurable. It's not a magic all-in-one solution. It will create the resources in code pipeline and code build on your behalf. So if we take a look at code pipeline, we can see that the pipelines for our deployment are defined here. So in the case of our Java app, we have this build and deploy steps, but we can change this and add it and add stages. For example, if we need a pre-production stage or homolog before going to prod, we can add that to our pipelines and add actions. For example, a very common one in this case is approval. So I should say go live manually before this action can be created. So well, there's a few some configurations you can do to notify an SNS topic, send an email to someone, or trigger another system. But the idea is that CodeStar is only a kickstart. It only creates the project and creates the pipeline, and you should adapt to your software development process, to your organization with the tools. For example, here's Code Pipeline. The other one we've talked about is Code Build. So this is Code Build, and our project is here as well. And our builds, we can see their history, their logs, and everything that happened on the project. So CodeStar again just creates these things. You can edit and adjust as you need. Okay, and a very interesting thing is that if you take a look at that code formation type reference, I should have a shortcut for that already. And here you can see, for example, that code pipeline can be defined in CloudFormation itself. So you can deploy not only the app with CloudFormation, but you can deploy the pipeline and the build. So you can have infrastructure as code. So it is a bit more complex, but if you run a central org that triggers several pipelines, this can surely make it easier, because you can have one provider of the artifacts, of the deployment artifacts, and trigger several deployment pipelines and keep them up to date. So you can say to your customer, hey, just create this pipeline on your account, and when I ship a new version, it will automatically update you. So this would be one way to implement things on a larger organization when you have to keep things up to date. And it's certainly harder to think about. There's this kind of barber paradox with infrastructure as code, and who codes the code for this. But, well, those are some very useful resources. Okay. So the ideas that we talked about are, well, first, make small, continuous, automated operations instead of bulk manual releases. And we've shown how to do it with Code Pipeline and CloudFormation. And by the way, Tom French, if any of you would like an internship or a job with AWS, I would be happy to help you with that. I think it's jobs.amazon.com. Here's our careers website. Let me paste that link for you. I would be happy to refer anyone if you just send me the job ID that you would like and your CV to myself. There's my email right there. Just ping me about it. I would be glad to help. All right? And so we can work together on this. Lots of interesting stuff. And well, here the key ideas for operational excellence are using those best practices of BlueGreen deployments, Canary deployments, the immutable servers, and maybe CQRS to ensure your application is stable and survives many deployments. When bad things happen, react to them automatically, and a good way to do it is shifting traffic using DNS. DNS may be a bit slow to respond, as we saw, but it is one way to do it. Faster mechanisms may require client-side knowledge, because if you want to respond faster than DNS is able to, you need client error handling and client error detection, as you see in MariaDB drivers and things like this. And it's a bit more complicated to build, but so if you consider effort and benefit, I think doing it on DNS is initially good enough. And we saw that CodeStar can build the pipeline, an initial pipeline for you from GitHub to prod in minutes, and you can customize and adapt to your software process. And the whole idea is that all the metrics and problems are shipped to CloudWatch, and you should react to that automatically. So let's take a look at how to do this in CloudWatch. For each of those metrics, so for example, for let's take a look at the latency alarms for ELBs that we were talking about. So this is a pretty good indicator of problems. If you see latency increasing, you should do something. So let's create an alarm on this. I just picked an ELB at random, but pick your application ELB and things like this. And again, this can be encoded into CloudFormation. So here you can see there is CloudWatch alarm, and you can include everything that we are doing here by hand. You can do it with code as well, okay? So latency too high. So when latency is more than, say, half a second for 2 periods of 1 minute, I want to set an alarm and enter a new list to the sys admins on Twitch, and for example myself, and take action. But the cool thing here is that you could also do things automatically. One example would be auto scaling. So for the so if latency is too high, maybe the response I want is to add one instance. So I will add one instance to this using this policy. I can add instances and do anything I would like, or even send a notification. And the interesting thing about the notifications mechanism is that it's not only for humans, right? If you don't, here is the confirmation for the email. But if we take a look in the SNS console and check these topics that we created, here's the topic for the sysadmins that I just made. This is just one subscription. I can create other subscriptions and add HTTP responses so that when something bad happens, when this alarm is fired, I can call another system through HTTP or HTTPS, send an email to someone, put a message on an SQS queue, send a push notification to an app, or send an SMS, or more importantly, call a Lambda function. And here is how you can respond automatically and call PagerDuty, call Twilio, call any other API, or do any kind of response, because Lambda is your code. So you can write a Lambda function that do anything and respond to the application's errors and respond to the problems in the way that's best fit for your process and your org. Okay, so with this, we've seen the important mechanisms for operational excellence, and I hope you understood how those things can work automatically. But if things do go off and you fail, it's a very important process that you write the solution and keep a knowledge base on your ticketing system, or wherever your wiki, or wherever you keep the run books. And because that's the list of things that you want to automate next. So if there is any failure or any condition that's not automated, take the steps you did, add to the knowledge base, and make that a subject for automation, and think how you're going to automate that so that your development process keeps getting better and better and more automated. It's very hard it's very, very hard to keep this 100% automated in a large enough application or organization. But the idea here is that you should target for continuous improvement and automating more and more with this tools. Like, so if you health check with Route 53, deploy with code tools, and monitor with CloudWatch, and React with SNS and Lambda, you can go full circle and keep improving your software process towards operational excellence. And this is it for today. I hope you enjoyed our broadcast. You have my contact details in the chat, and I would be glad to help with anything at all you guys would like. And if there's anything specific you would like to dive deep, let me know, and I can approach this on our next broadcasts. The next one will be a review of all well-architected topics. So if you just jumped in today or would like to recap all the topics that we've discussed and the most important tools, I would be glad to help. Thank you guys. Thank you for participating. Mark, Tom, it was Bundy. It was great talking to you. I hope I see you next time. Thanks. Bye-bye.